Thanks for everyone who came to my talk today. I'm excited to present at LASCon. It's one of the first conferences I went to a few years ago when I started my career, so it's cool to be up here on the other side. I am curious, who here is already familiar with JWTs? All right, and who has strong opinions about them? Okay, that's actually reassuring, because I was worried people were going to throw things depending on my takes and how spicy they were, so glad to hear it. Well, wait till the second half of the presentation. So a little bit about myself. I'm currently a senior security engineer at Instacart. I previously had a few roles. I started in product management, but moved to security pretty early in my career. I was the first security engineer at Favor Delivery, which is a really cool experience. My educational background's at A&M and Georgia Tech, and I have a pretty inactive Twitter account, but you're welcome to follow it. Send me DMs if you have any questions after the talk. And my intended audience here, obviously, based on the conference we're at, is application and product security engineers, also developers who may be interested in doing things more securely, or authentication and authorization. And my goals are to give a brief overview of JWTs, but assuming some basic understanding of them and familiarity, and going over, obviously, the good use cases or patterns, and some potential bad use cases or anti-patterns. So bear with me if you're already familiar with this, but a quick overview of JWTs. I'll often use the term JWT, which is the same as JWT. My first job where we worked with JWTs, I found this really confusing. I was in these meetings and people would be talking about them, and I thought for a good month that we had two different types of authentication tokens, JOTs and JWTs, but they are in fact in this context the same thing. And of course, it stands for another acronym, JSON Web Tokens. This is a screenshot I took from JWT.io, which is a useful website when trying to evangelize JWTs or when you're working with them, though I wouldn't paste production data in strange third-party domains. But if you look at this, color coding is quite useful for understanding the various parts. So a JWT is made up of 3 parts. The first 2 are URL base64 JSON. You can see the header, then the payload, and then the signature at the bottom. So the header will typically include this type, or JWT. And you can see this is JSON as implied in the name. So basic sets of like key value pairs, a signing algorithm, which in this case is HMAC SHA-256, and then the payload, which has these claims, which are really the most relevant part usually for developers who are working with these. Things like username, when it was issued, really anything you theoretically could include in these. And that's really where the power of them is coming from in most cases. And then lastly, you can see how the signature is constructed. So it takes an HMAC of the base64 URL encoding of the header and payload. These are delimited by a period. And then you have the secret. And that's that blue piece is the signature. And that can be symmetric or asymmetric. I also wanted to touch on this. This is a screenshot from the RFC for JWTs. And I talked a second ago about how you have these claims, these like key value pairs. There's several that they suggest. They're all optional, but several that they suggest in the RFC. So issuer, they're pretty self-explanatory, but you have issuer, subject, so that could be like a domain, or who the JWT is, what domain it might be scoped to, an audience, so who might be intended to actually use the JWT or consume it. And a lot of these are most useful when you're working with things like federation. You have expiration time, a time you can specify not before, so in the future, or even in the past, I suppose, for a token not be valid before that time, the time it was issued, and then a non-deterministic and unique ID for the JTI. And again, all optional. So I also wanted to talk a little bit about terminology to make sure we're on the same page, because I often see people on the internet debate, JWTs versus cookies. And of course, cookies strictly defined, cookies are like an HTTP cookie. So a way to store data in a web browser, adding state to HTTP, But in this JWT versus cookies discussion, people are usually using cookie to refer to the traditional randomly generated session key, which is often stored in a cookie, but they're not mutually exclusive with JWTs. I'm assuming most people here are relatively familiar with the basics of cookies. JWTs, we already covered the basics of what a JWT is. Again, they can be stored in a cookie, not mutually exclusive with that concept. There's also this term stateless tokens. So JWTs are a subset of stateless tokens. There are other implementations, including Macaroons and others. I'll touch on a few of these as well later. Then server-side session, I just mentioned these. So this is where you have like a random identifier, hopefully 16 or 32 bytes long. This is your traditional idea of like a session token. I also have this cookie recipe, another type of cookie from Clifford, Stoll's The Cookie's Egg. Excellent book if you haven't read it. Excellent cookie recipe as well. I prefer to brown the butter, kind of a intermediate technique to up your cookie game, but another type of cookie. And then I also wanted to talk about where you might encounter JWTs as a developer or as a security engineer. So there's a few areas. So one would be this like session token example. So web applications or mobile applications, API tokens. You have standards like OAuth and OIDC that can make use of JWTs, and then service-to-service authentication. So either inside a network or between multiple networks. And then I also wanted to discuss why people use JWTs. I don't necessarily endorse all these. These aren't arguments in favor of JWTs, but particularly as security engineers, we'll come across these, and it's good to understand what people were thinking at the time. So firstly is this stateless idea. Databases can be expensive. Making a call to a database on every request is something that developers like to avoid. And the idea with the stateless token is instead of having a session token you store in a DB and that you need to check on every request, you can replace them with stateless tokens. So you sign the token, you issue it, and then you can use that instead, and you don't have to make checks against the DB anymore. Another reason that people often use JWTs is the service-to-service auth. So service-to-service auth is, in my experience, very hard. There's no silver bullet I'm aware of that has no downsides and perfectly solves the problem. But there's a lot of appeal to using something, a stateless token, and in particular a JWT, in that if you're already using it as a session token, you can continue to pass that around from microservice to microservice, or you can sign requests as they come into your network, some sort of auth service, and then have that be validated with a shared key that the microservices have. And I'm going to talk a little bit more about this in depth later on. Also, it's really popular. So here's a tweet I just found, hashtag JWT, hashtag WebDev. Obviously, JWTs are cool. This tweet has 41 likes, so it must be good. Also, as developers know, if you just smoosh HTTPS, HMAC, and asymmetric keys together, it's super secure because, I don't know, there's a lot of crypto words in there, so it must be good. And then also, as a security engineer, this is probably the big reason you'll encounter JWTs. They're already there. You might do a security review. You might join a new company, and they're using JWTs. Maybe you don't have the political capital, the time, the developer resources to remove them, fix them, but still want to discuss ways to improve them potentially. All right, so why do people dislike JWTs? Why might you or someone else not use them if they're so great? So first of all, my obligatory HackerMan art that you have to include in all conference presentations. So revocation is a hard problem with stateless tokens because if they're purely stateless, then essentially it's impossible to revoke them because without removing the signing key. Otherwise, we'll need to introduce state in some way. And I'm going to talk about like good and bad ways to do that, but revocation is a difficult problem. Also, Hacker News doesn't like JWTs, and so if you tell them you use them, you'll get flamed. I don't know if you care about that, but it is a potential downside. Also, cryptographers don't really like JWTs, so just, if you do use them, I guess be careful who you tell. This is just a crude example that I wrote out of illustrating some of the potential foot guns that come with JWTs. So by design, the specification is very flexible. I mentioned earlier, I talked about the header, where you have this type, JWT, and then you can specify your signing algorithm. So in the first line, we have an HMAC SHA-256, great, symmetric. We have an RS-256, or RSA-256, I mean, fine, good enough. And then lastly, you can specify algorithm none. And this is something that the spec supports. If you're familiar with JWTs, you may be familiar with these types of attacks. But this is actually supported. You also could just leave out the algorithm field. And for those who aren't familiar, what this has enabled fairly often is these attacks where an attacker can simply design their own JWT, specify alg none, and then send it to your backend. And then your JWT library will say, oh, that's fine then, because there's no signing needed. It says algorithm none, and then it will let you have like admin permissions or whatever you want. And while this is a known issue, it is also an issue that has been patched, but it is a recurring theme and something that I wanted to highlight in that the flexibility of the specification can bite you. It's also in the same vein, trying to be everything to everybody. It's a very, and complexity is relative, but there's a lot going on if you read the RFC and a lot of the uses and implementations. So having a Swiss Army knife in security can be a bad thing sometimes. So again, tread carefully. All right, so diving into some of the specific, as advertised, anti-patterns and patterns. So this is probably controversial to some of you, but I think that JWTs as sessions is a pattern to be avoided if possible. There are ways to put safety rails around things, to do revocation in a better way that I'll discuss in a minute, but it's really not the exact situation they were designed for, and it's where you get a lot of these, you have to start putting up a lot of the guardrails where for a lot of use cases, it would have been easier to just go with something simpler. Also, including secrets and claims. This is a relatively common issue where, as you can see, I've constructed some JSON here where I've decided to include the signing key, the user's social security number. This, I think, comes from the fact that JWTs look encrypted if you don't really know about encoding or the difference between a MAC and like encryption. And so developers who aren't as familiar will just see something that's base64 encoded and think, oh, it's encrypted, so I can just pass this to the user side or anyone who wants it. You can actually encrypt JWTs, but generally speaking, information like this, you wouldn't want to pass to the client side. Also, this I know is a debate in and of itself, but this is something I've seen particularly with JWTs for some reason. There's a propensity to store them when used as session tokens in local storage as opposed to in a cookie. So this removes, and again, I'm happy to talk to folks about this afterwards. I know there's some nuance here, but generally speaking, you're removing some potential XSS protections like same site on your cookies, and incidentally adding CSRF protection because the browser won't automatically attach them from local storage. But again, for some reason, people really like to put JWTs in local storage. So if you think it's something to be avoided, it should be especially looked at for with JWTs. And then also attaching them with JavaScript. This is something I've seen in production before. So same type of thing, but can also happen with cookies where we have our JWT. It's signed, it's great, it has all sorts of information in it. And then I construct my header on the client side in JavaScript to send along with my request. And I'll manually create this authorization header and specify it's a JWT and stick the auth cookie on. And it's the same sort of risk here of you're having to allow your tokens to be accessible to JavaScript and therefore having to disable things like HTTP only protections. Another one that's very JWT specific is weak HMAC secrets. So if you're going down the symmetric route, it's important to choose good secrets for signing. So this should be 32 bytes. You don't want them to be human readable, like a password, and definitely don't reuse them from somewhere else in the infra, and obviously don't mix your non-prod credentials with your prod credentials. All right, this is another one I've seen a lot on the internet or even in production, is this no revocation idea. So the idea is that we have these stateless tokens. but they only live for 15 minutes. So no one will ever hack us and then be able to use them within 15 minutes. It's impossible. Or our scale means that it won't matter because we're too big or we're too small. But having the inability to revoke tokens for a user account for an individual token can potentially increase the scope of things like a vulnerability like XSS, phishing, taking over ATOs, things like that. Especially for consumer applications, it's really useful to be able to target individual accounts or even individual sessions and end that session without having to rotate an entire signing key and validating everyone's session. Usually that's bad for growth metrics and things that executives care about. And I think it's also obviously potentially important for B2B as well. In the same vein, you have no expiration. So this I've seen too with regular session tokens, but if you have an application, consumer-facing application, maybe it allows you to order widgets on the widget store. It's bad to make users have to sign in because users forget their password. So if we just never make them sign in ever again, then that's good. We'll make more money. It's hard to argue against that, but from a security perspective, it's less than ideal to have infinitely lived tokens. And in JWTs, it's as easy as not implementing an expiration field or a claim. So it's often overlooked or purposely excluded. This one as well, I'm going to touch back on this in a second in the pattern section, but I think it's an anti-pattern for JWTs to have a revocation database. So the idea here is that, okay, we have people who log out, we have ATOs, we have deleted accounts, and we want to invalidate their sessions. So we'll create a table in the DB, we'll stick the JWT in there, or maybe just the JWT ID, and then when we get a request, we'll go check that database on every request and see if this JWT or JWT ID is in the table. And you solve the revocation problem, but you've really gone back to the most primitive way to do like session tokens at that point. You're having to make expensive database requests on every request to your backend. You have this table that, if it goes down, I guess it's good in that you could keep serving requests, but you could be serving requests to malicious users. You could also keep this table from getting too big. So that is an advantage over like a regular session table. It won't get gigantic as quickly if you're a fast-growing startup, for example, because the number of revoked tokens should be a lot smaller than all existing tokens. And you could create a cron job to clean it up when your tokens expire anyway. But again, you're kind of back to square one in terms of statefulness and added latency for authorization and authentication. This one, I think, is also could be controversial. There's a number of well-vetted schemes by people smarter than me that use refresh access token pattern. I'm referring more to it in the sense of rolling your own refresh access token scheme. First of all, it's complex, and I'm skeptical of some of the benefits. If you're unfamiliar, and again, this is referring less to like a specific implementation or standard and more to ways I've seen it homegrown, but the idea is that instead of issuing a single token, like your session token or your JWT as a session token or as an API token, you issue two tokens. So one is an access token, which is like your normal token. It's attached to requests, and you use it to access the API. It's typically short-lived, and it's sent over the wire more often because you're making these requests to order widgets or update your password. Then you have the refresh token. It's longer lived, and it's only used to hit like a dedicated endpoint to get new access tokens. I've seen people argue for this in a few different ways. One being that, oh, well, we don't send the access token over the wires often, so if someone has like a man-in-the-middle attack, then it's unlikely they'll be able to steal the refresh token, or it's less likely. It doesn't really fit with my threat model with like TLS and how man-in-the-middle attacks might work in 2021. Additionally, I've seen it, like we can lock down the refresh token more. Again, for like web applications and things like that, I just haven't really seen a convincing argument for that in my opinion. So I would consider it an anti-pattern to add this complexity. Another interesting thing I've encountered is having like fragile built-in key rotation in your backend. So To rotate a key with a stateless token like JWT, it's painful because all the tokens you've issued will be invalidated. A scheme that I've seen to mitigate this is having a bunch of keys. So it could look something like you have this key generation service. It, every week, let's say, makes a new key. And then your service that validates JWTs, it has a whole set of valid signing keys, and then every 90 days, the oldest one it kills. So this allows you to limit the blast radius if you need to kill a signing key for some reason. But it's hard for me to think of a threat model in which you need to invalidate a single signing key. Like one signing key is compromised, but the rest aren't. So you've added on this complexity that may potentially open you up to some sort of vulnerability with, in my opinion, a pretty little amount of security gain. Another interesting anti-pattern is just creating fully stateful JWTs. So you buy into JWTs, you issue them, you sign them, but you really get rid of the idea of statelessness. You just take a JWT and you put it in your database, and on every request, you go check the database and see if the JWT is in the DB. At that point, you've eliminated a lot of the potential benefits. And you're still accepting potentially the risks that come with using a somewhat complex token type like a JWT. Additionally, I've seen multiple overlapping implementations. So obviously with API versioning, this can be done correctly, where maybe you're moving to JWTs, maybe you're moving off of JWTs, you increment your version number for your API, and then your router and code will know how to handle those different situations. However, in this situation I'm referring to, the same version could accept multiple types of tokens. So it'll accept a session token and a cookie, a JWT, a refresh access token pair. I think this is one of those patterns that goes beyond JWTs, but the whole appeal at one point and now maybe fading popularity, I think has led to this more. And it's not hard to imagine weird and hard to find vulnerabilities that could emerge from accepting multiple types of tokens and authorization for the same endpoints. All right, so I also want to talk about ways you might improve JWTs or use them more safely. This is a brief aside just talking about service-to-service auth to set up the stage. So this is my crude diagram of like your classic auction service. We have the internet, a load balancer, this like router microservice, and a few other microservices. These services can talk to other internal services and some databases, but there's no service-to-service auth. Instead, we're relying on network connectivity rules and maybe database credentials for the DBs. Of course, there's technically like a perimeter around here with security groups or something similar. So nothing in the outside world should be able to communicate except through our firewall and our router service. And this is really the most common, I think, approach to service-to-service auth is to simply not implement it. It's certainly the least complex, and it can be sufficient depending on your threat model and where you need to spend your resources. So this is a simple illustration of how someone might add like bearer tokens to this. So as you can see, I just overlaid some like 2 short tokens. The idea is that there's a bearer token attached to every request. When a request comes to the network, then the router service can attach this like session token like item, and then the other services have a copy of this, and they'll see that the session token, or not quite a session token, but that this bearer token is attached. Therefore, it must be coming from someone I can trust. Obviously, there's some problems with this in that an attacker in the network who's able to intercept requests could grab this token pretty easily and just send it along for any request they want to make against services. This is another kind of convoluted illustration of another way you might approach the problem. So you have an auth service, and then every request is signed or has a token added to it by the auth service, which is then validated by the auth service again. I don't know if anyone's really doing anything like this because that's a lot of latency to add. You also add this like single point of failure in your auth service. But JWT, the problem it's trying to solve potentially is those weaker implementations can be replaced with signing your request in the network with a private key, and then just issuing the public key to all your microservices and having them validate that the JWTs that the requests have the valid JWT. And if you are using JWTs as session tokens or API tokens, then you can even use those tokens as part of this signing scheme potentially. If you, for example, run Roblox and you need to ban people, then you can use revocation via cache. So this can be implemented on top of the database example I gave earlier, or in and of itself. I know several companies are using this in production, or some version of this. Using an in-memory DB, Redis, a key value store, to store a list of invalid but not yet expired tokens is a relatively low latency way to have some ability to do revocation. The cache should stay pretty small, and especially with Redis, it's easy to set TTLs equal to your already existing expiration time, and so it'll automatically keep the cache size pretty low. Another useful thing when you're thinking about like secure library development or how to make this easier for developers not to shoot themselves in the foot is hard coding the algorithm. So this is a little Python snippet. You can see I have a very poor key chosen, and then encoded is equal to this JWT token that I'm creating. On the decode part, though, you'll notice that this library allows me to specify the algorithms manually. I can also choose not to pass it. This is just how the library wrote this function. But by specifying the algorithm, I'm helping insulate myself against, potentially, against some of these like alg-none type attacks. And a potentially even more robust way of doing this is write some sort of like JWT libraries or functions for developers to use, where inside we've defined where the key is being pulled from, hopefully not hard-coded, but being pulled from somewhere, maybe like an environment file or included on build. And then we specify the algorithm for them. So developers don't have to worry about all the knobs and levers. And I think this is a useful pattern a lot of us are probably familiar with cryptographic constructs in general. Also, you can potentially just not use JWTs. There are, again, some of these other items that are popular. Macaroons are, I'm gonna touch on them in a little bit, but they're a somewhat unpopular but interesting construct with like a stateless token. Pasetto, in some ways, is like a JWT with some hard coding some of the better attributes of JWTs and not having to worry about as much flexibility to hurt yourself with. Or if you're really just doing a non-web scale web application or mobile application, you're probably safe with session tokens. A lot of the scaling issues, latency, things that people often want to use JWTs to solve may not be an issue for you, or there may be simpler solutions. This one also goes way beyond just JWTs, but use trusted libraries. JWT.io has a list of libraries in different languages. You should keep it up to date for those persistent algorithm none attacks. I mentioned this earlier, registered claims. So there's a few that I think are particularly useful. Subject, expiration, and issued at time, I think are really table stakes kind of things that should be included. Key ID is also useful. And then JWT ID. So key ID is for like identifying which signing key you've used for this particular JWT. And then JWT ID is for the specific JWT, and that could be used for like revocation purposes. I also wanted to go over a few like additional topics and resources that you might want to explore on your own. So RFC 7519, this is the original JWT RFC. It's an interesting read potentially if you're working with JWTs or authorization and authentication. It's interesting to understand some of the more nuanced details and what the developers of the RFC had in mind when they were developing JWTs. There's also this more recent and much shorter RFC, 8725. It has a number of best practices for using JWTs and for implementing JWT libraries. So some may be more or less relevant to your use case, but I found that a really interesting read. Macaroons, this is something that I've never implemented myself, but you can read the paper on them. They do have a very delicious name, obviously. I've heard them macaroons, depending on who's pronouncing it. But it's interesting in that it has this chained HMAC construction. So it allows for things like delegation. It allows you to issue tokens that can issue more tokens. It allows for caveats, so sort of the inverse of claims where you can remove specific accessibility from things. There's also this great blog post, Stop Using JWTs for Sessions, which it's two-part blog post, which has this awesome flowchart about why the author thinks that JWTs are not a good choice for session tokens. And then this is an awesome blog post from Latacora, if you haven't read it. It's about just different approaches to service-to-service authentication. It goes way beyond the few crude examples I gave into a lot of different options and the pros and cons potentially. And if you're interested in this topic, I'd encourage you to look into a few other areas. So federation, this is something I really didn't touch on, and one of the core use cases for JWTs in like 2021 is these popular protocols for things like single sign-on and federation. And obviously a really valid use case is when you have to interact with JWTs to work with something like an OAuth 2.0. There's some other interesting constructs like JSON web key sets and JSON web signatures that I'd also encourage you to look into if you're interested. I'd love to take questions now. I know also that this wasn't a Instacart specific talk, but of course we're hiring. I'd love to talk to anybody who's interested in what we're doing. Yes?
Can we get the slides and the recording of the session later sometime?
Yeah, I think this usually posted. I might upload the slides and like put them on my Twitter then too.
You just put them on the last website, or?
I'm not sure. I think that the video is uploaded to the YouTube channel at some point after the conference for one thing.
Okay. And the slides, like?
I'll post them on my Twitter.
Twitter?
Primed Mover. Yeah. Or just David Gilman.
Okay.
No, no worries.
The other one was David, what was his last name?
Gilman, Gilman.
It's in the program.
That too. Any other questions? All right.